Now we are ready to start talking about overriding or giving the subclasses their own characteristics in addition to what they've received from their parents. So in this case, we could argue that, well, baseballs have different behavior of bouncing. So baseball may bounce differently from any other kind of ball. We could go ahead and say override behavior. To override a behavior, we simply say override, that's the keyword, and we say func bounce. You notice I didn't have to type a lot of things here. Most of it was automatically written for me. The reason being is because, as you can see here, we said override func bounce. Notice the bounce has to be the same as the bounce from our base class, our parent class, because that's what we're doing. We're overriding. We're saying we still want to use that bounce. Instead of using my parent's bounce behavior, I want to use my own bounce behavior, which characterized me as a baseball object, not just a ball. We can just go ahead and say return. I bounce like a baseball. And now here at the bottom, my baseball instantiated is here. We can go ahead and access that method. The moment you say dot notation, so you can access all of this, there's the bounce, and look what's going to happen. I bounce like a baseball. It's not showing the bouncing from our ball here. Why? Because we said override that method. So you can start seeing the power of object-oriented programming, because now not only we have a baseball object that has its own behavior, it is indeed overriding the parent's behavior. Obviously, we can go ahead and add other behaviors here that are particularly for our baseball if we wanted to. In this case, we don't need to override anything. We can just go ahead and say func show color, for instance, right? And we can pass in a color string, and we make sure that it returns a string. And here we can say return color. There we go. So you can see now we have this show color func, which is not being overridden from anywhere because we don't have any other behavior in our ball class here, which is the parent, right? So we are creating this method, this function here inside of our baseball. So this is just for our baseball. You can see if we go print here my baseball and say, for instance, show color, there it is. We of course have to pass in a string and say blue. Okay, let's get rid of all of this extra residual. And you can see my baseball.show color is blue because we've passed in the blue there. We are also able to add properties. So new properties. Let's say if we want to add a name property, we can go ahead and say private, right? Var name, and we say string, okay? And then go say private, var is round, okay? Let's make this a boolean, so true or false. So now we've added these two properties here. So name, which is a string, is round, which is a boolean. And we say private because we want this to just be accessed inside of our file here. Okay, now we have a problem here. If you click on this red warning here, says class baseball has no initializers. We need to initialize our new property. And we could have gone ahead and say just like this, put an empty string there and put here say false. That would solve the problem. But since we have learned how to actually use an init method inside of our classes, let's just use that then. Instead of hard coding as we did here, let's get rid of this and this one here as well. We are going to get an error again. We say init, open parenthesis, and let's pass in name of type string and is round of type boolean. It's a method, so we have our braces there. Now inside here, this is where we're going to be initializing our baseball class, which inherits from our ball. Okay, now notice something very interesting here. You see I said name and is round as the parameters that I'm passing in, which coincidentally are the same name, have the same name as our private properties. Now, this is not required, but I always do this way because it makes it much easier for me to know what I'm setting up, because I would know its name and is round. And also notice when you use this way of doing things, having the same names as the properties in our parameters, this is when we use this self in order to set our properties inside of our init, because that's the whole reason why we have initialization, because we want to set things up. all right, for our object. We say self dot, and then we are taking the property of our object here, baseball in this case. First one is going to be name, this one here, and you can see right away there's a little dash thing that happens at the bottom here, which signifies we are indeed talking about this property here. So we're saying we want this property name to be equal to receive what we are passing in our initialization. So when we pass here, say color, new color, that's exactly what's happening. We are saying then taking this color and pass inside of our property. Of course, in this case, it's a different property, but you get the idea. And we do the same, self dot is round is going to be equal to whatever we pass in our parameter. So we're taking this is round, it's passed in, and we are setting our is round property to be whatever we pass in. Before we do anything, we're going to call super. So super is our parent class, which means we are calling now our ball here. We want to call its init, which is this one here. So we say super dot init. There it is. Obviously, we have to pass in a few things here. So we can go ahead and just pass in, say, green, and for size, let's say 12. Now, right away, we have an issue here in our instantiation where we instantiate our baseball object. If you could click, it says cannot invoke initializer for type baseball with an argument list of type color. The reason why it's happening because we already called here super init color and we passed in everything. What we need to do now is actually call our own init here because this init is already done because this is from super, which is the parent class. All right. So what's happening here, this my baseball is saying, well, I don't know what you're talking about, this color thing, because I have no idea what that is as far as I'm concerned, because I'm only concerned on my init unless I am called as super. So that's why we're having this error here. So we need to actually go ahead and use name as and is round as our parameters here to initialize it, because that's exactly what we did here, right? In our baseball class, which inherits ball. We're going to go and say open parentheses, and right when you open parentheses, it gives you the correct parameters or arguments you need to pass. In this case, name, so say tab, let's say baseball, and is round, let's say true. Okay, because again, it has to be a Boolean, so true or false. There we go. Now we have my baseball object instantiated correctly. And now to make sure this works, let's get rid of this. Let's go ahead and say my baseball dot size. Let's see what size it's going to give us. It's giving us 12. Why? Because if you look here in our init, we initialize size to be 12 because we are inheriting from our main ball class. And I can do the same. I can say, let's put comma and say my baseball again dot, for instance, name. Let's guess what's going to happen. It says baseball because we said our name of this is going to be baseball, right? And if we go ahead and say my baseball dot is round to see if it's round, it's going to say true because we said is round is true. Now let's check something very interesting here. Let's go say print my baseball dot bounce. What's going to happen? I bounce like a baseball. Why? Because we already overrode this bounce method here because it's not calling the bouncing. All right, it's great. So you've learned how to override functions, method, in classes, and you've also learned how to even add other behaviors in the subclasses, and also learn how to create new properties in the subclasses, but still holding all of the properties and behaviors from our parent classes. So go ahead and play around with this concept here. And I understand it may be a little bit confusing at first, but trust me, the more we look at this, the more we learn about this, the easier it becomes. So just go ahead and write your own classes. So in the next video, we'll continue talking about inheritance. And one more thing that I would like to share with you before we proceed into other things. All right, so I'll see you next.